It's my great honor to give a presentation here today. My name is Binghua, and the topic I want to talk about is CMS, Component Missing Strategy for Augmentation on Motor-Imagery Signal. Brain-computer interface system is designed as a bridge between human thinking and external devices, among which EEG signal is one of the most widely used for its convenience. Motor imagery is a kind of EEG, which has attracted much attention for it is spontaneous rather than evoked by external stimulus. However, the motor imagery signal recorded in experimental paradigm are usually limited in amount for invalid data caused by fatigue of subjects. In the past decade, some researchers tried to improve the performance of motor imagery signals under small amounts of data. For example, Professor Sichowski tensorized the motor imagery frames with wavelet transformation. They claim that tensorizing enriches the representation of trials. Professor Fabian proposed to generate artificial motor imagery frames by randomly mixing the segmentations of raw trials. Some researchers stepped further to generate artificial frames by randomly mixing the components obtained by EMD, so that the artificial frames can contain time frequency information of the raw data. In spite of these researches, there are still 2 points we can go further. Can we tensorize the motor imagery frames after augmented by missing components? Do other decomposition methods except EMD take effect? To cope with the questions, we propose the component missing strategy for motor imagery augmentation. We first split the test data and the training data, then split the training set with their categories. We subsequently decompose the selected parent signals and mix their components randomly to generate new frames. The wavelet transformation can then follow to tensorize the new dataset. We first test the EMD-based CMS on our experimental data. WNN denotes the wavelet neural network, and we apply datasets with different amounts of additional artificial trials for training. We can observe that doubling the raw data with artificial motor imagery frames and tensorizing the data before classification can achieve remarkable improvement. We further validate CMS in the public dataset. We set 4 different ratios of training sets, 3 different classification models, and 3 different decomposition methods are discussed. We analyze the distribution between raw data and the artificial data with TSNE. The results shows that the artificial trials are clustered around raw frames. We then plot the mean power spectral density of raw data and artificial data. We find that the generated data and raw data share some similar trails on frequencies. For the results on binary accuracy and AUC score, we claim that CMS can improve the performance in most cases. Over 10% improvement can even be observed. In summary, we want to claim that adding additional data generated by missing components and then tensorize before classification help improve the performance. EMD, MEMD, and ITD-based CMS all take effect. That is all for my presentation. Thank you for your attention.